The ocean has always carried an air of mystery. Even in an age where satellites map distant planets and robots explore Mars, humanity still knows surprisingly little about the deep sea. Vast regions beneath the surface remain untouched, unseen, and unexplored. It is in these dark waters, far below the reach of sunlight, that one strange discovery sparked theories about hidden predators, ancient monsters, and the terrifying possibility that something enormous may still roam the depths of the Pacific Ocean. The story began near Isla Guadalupe, a remote volcanic island located roughly 130 miles off the coast of Baja California. Surrounded by cold, deep water, the island is famous among divers and marine researchers for one reason: great white sharks. Every year, these powerful predators gather near the island to hunt elephant seals and sea lions, making Guadalupe one of the best places on Earth to observe them in the wild. During one expedition, researchers studying sharks noticed something extraordinary. A massive female great white shark swam past the underwater cages, but it was not her size alone that stunned the divers. Across her chest and midsection was a giant circular scar. It looked as though some enormous set of jaws had wrapped around her body and attempted to crush her whole torso. For several moments, everyone observing the shark froze in disbelief. The wound was unlike anything the team had seen before. This was not a scratch from a propeller or a minor injury from hunting prey. The scar formed a nearly perfect ring, suggesting an attack from a creature with a jaw far larger than any ordinary shark. Even more shocking was the fact that the female shark had survived the encounter. That detail alone raised disturbing questions. Great white sharks are already among the ocean's top predators. Adult females can grow up to 20 feet long and weigh more than 4,000 pounds. Built for power and speed, they are evolutionary masterpieces that have ruled the seas for millions of years. Their bodies are covered with dermal denticles, tiny tooth-like scales that create armor-like skin tougher than many people realize. Leaving a permanent scar on such a creature would require tremendous force. Yet the mark on this shark suggested something powerful enough to overpower a predator that most animals avoid entirely. Marine biologists immediately began analyzing photographs of the wound. The geometry of the bite became the biggest mystery. A normal great white shark, even a large one, does not possess jaws wide enough to leave such a symmetrical circular mark around the body of another adult shark. The spacing between the apparent tooth impressions hinted at an attacker of incredible size. Some scientists propose that another great white shark may have been responsible. Shark aggression is not uncommon. Great whites are mostly solitary animals, but when they gather around feeding grounds like Guadalupe Island, strict hierarchies emerge. Larger sharks dominate smaller individuals, and conflicts sometimes occur over territory or food. Usually these confrontations involve warning bites or quick displays of dominance. A larger shark may bump or nip another shark to establish authority. However, the scar on the female shark appeared far too severe to be a simple warning. Instead of targeting the head or gills, which are common during shark fights, the attacker appeared to have bitten directly around the center of the shark's body, as if trying to immobilize or consume her. Cannibalism among sharks is a documented phenomenon. Larger sharks frequently prey upon smaller sharks because they provide a high-energy meal. But this female was not a juvenile. She was a full-grown, 15-foot predator. For another shark to attack her as prey, it would likely need to be enormous, perhaps 25 to 30 feet long. That possibility pushed speculation into unsettling territory. The largest reliably recorded great white shark, often referred to as deep blue, measures around 20 feet in length. A shark approaching 30 feet would shatter modern scientific records and dramatically alter current understanding of shark biology. Some researchers believe that extremely old great whites may migrate into deeper offshore waters as they age, feeding on large marine animals far from human observation. If true, such giant sharks could remain hidden in deep ocean environments where humans rarely venture. The mystery deepened because the ocean itself remains largely unexplored. Scientists estimate that humanity has carefully mapped only a small fraction of the seafloor. Beneath the surface lie underwater trenches, canyons, and abyssal plains that descend thousands of feet into darkness. Pressure at those depths becomes immense, making direct exploration difficult and expensive. creatures living in those regions could remain undiscovered for decades. Many marine experts point out that the ocean functions like a layered world. Surface ecosystems differ dramatically from those found in deeper waters. Animals adapted to life in darkness may occasionally rise towards shallower depths, especially when following prey or changing environmental conditions. This realization transformed the scar from a biological curiosity into something far more haunting. The wound seemed like evidence that even apex predators are vulnerable to unknown dangers lurking below. One theory initially considered by experts involved shark mating behavior. Male great white sharks often bite females during mating because they lack limbs to hold on to their partners. These mating scars commonly appear around the fins or upper body of female sharks. However, specialists quickly ruled out this explanation. Typical mating bites are shallow, irregular, and concentrated near specific areas of the body. The Guadalupe shark scar was deep, symmetrical, and positioned incorrectly for a mating injury, instead of looking accidental or chaotic. The bite resembled a deliberate predatory strike. The space in between the marks suggested jaws far larger than those of any male shark known in the area. Naturally, attention turned toward another famous marine predator, the orca. Orcas, also known as killer whales, are among the few animals known to hunt great white sharks successfully. Highly intelligent and cooperative, they use teamwork to overpower prey much larger than themselves. In South Africa, researchers documented orcas targeting great white sharks, specifically for their nutrient-rich livers. These attacks terrified local shark populations so severely that many sharks abandoned their hunting grounds entirely. Yet orcas did not seem to match the evidence. Their teeth are conical rather than thin and serrated like shark teeth. Orca attacks usually leave ragged wounds where tissue has been torn apart, not the clean circular impression seen on the Guadalupe shark. With known explanations falling short, speculation intensified online and within popular culture. Soon one word began appearing repeatedly in discussions surrounding the mystery: megalodon. The megalodon was a prehistoric shark species that lived millions of years ago and may have reached lengths exceeding 50 feet. Its bite force was among the strongest ever estimated in the animal kingdom, and its teeth, some as large as human hands, continue to fascinate scientists and collectors alike. Officially, the megalodon became extinct approximately 3.5 million years ago due to changing ocean temperatures and declining prey availability. However, some enthusiasts believe isolated populations may still survive in the deepest, least explored regions of the ocean. To these believers, the bite mark on the Guadalupe shark seemed like compelling evidence. They argued that the circular shape and enormous size of the wound resembled the jaw structure expected from a smaller or juvenile megalodon. Though mainstream science strongly rejects the idea of surviving megalodons, the mystery reignited fascination with the possibility of hidden prehistoric predators. Adding fuel to these theories was another strange event that occurred off the coast of Australia in 2014. Researchers had attached a tracking tag to a 9-foot great white shark to study its migration patterns. Suddenly, the tag recorded a rapid descent to depths nearing 2,000 feet. Then something even stranger happened. The temperature registered by the tag spiked dramatically, indicating it had entered the digestive tract of a much larger warm-bodied predator. The shark had apparently been eaten. For days, the tag continued transmitting data from inside the predator before eventually resurfacing. The event sparked widespread speculation. Some scientists suggested a large marine mammal could have swallowed the shark, while others wondered whether an unusually massive shark had consumed it. Although there was likely a rational explanation, the incident became linked with the Guadalupe shark mystery in the public imagination. Theories grew increasingly imaginative. Some researchers discussed the possibility of relic populations, descendants of ancient predators surviving in stable deep-sea environments largely unchanged for millions of years. Deep thermal vents and abyssal trenches create isolated ecosystems where evolution may follow unexpected paths. Others propose that abyssal gigantism, a phenomenon where deep-sea species grow unusually large, could explain encounters with giant unknown predators. Gigantic squid, enormous isopods, and massive deep-sea fish already demonstrate that extreme size can evolve in darkness. Perhaps an undocumented species of sleeper shark or Greenland shark had adapted to deep Pacific trenches and grown to astonishing proportions. These sharks are normally slow-moving scavengers, but they are opportunistic hunters capable of consuming large prey. A supersized deep-water shark ambushing a great white in cold, low-oxygen conditions might explain the devastating wound. Another theory involved colossal squid. Sperm whales routinely battle giant squid in the deep ocean, leaving scars from the squid's serrated suction cups. Some speculated that a giant cephalopod could have wrapped itself around the shark, producing a circular injury that resembled a bite mark. Though speculative, the idea highlighted how little humans truly understand about interactions occurring thousands of feet below the surface. The shark's survival remained one of the most remarkable aspects of the story. Sharks possess extraordinary healing abilities. Their cartilage-based skeletons heal more efficiently than bone, and their immune systems appear highly resistant to infection. Researchers studying shark biology hope these adaptations may eventually inspire advances in human medicine. The Guadalupe female likely survived because the attack was brief. Perhaps the predator misjudged her size or strength. Perhaps she escaped before the attacker could finish the kill. Whatever happened beneath the water probably lasted only seconds. Predatory encounters in the ocean are often sudden and violent. Great white sharks can reach speeds exceeding 35 miles per hour during attacks. In dark water, clashes between giant predators may begin and end before anyone nearby notices. The only reason this mystery became known at all was because the injured shark later passed close enough to cameras for researchers to document the scar. That realization carries an unsettling implication. How many similar encounters occur unseen every year? Marine biologists frequently point out that humans observe only surviving animals. Injured sharks that escape attacks may later be photographed or tagged, but those that fail to survive simply disappear into the deep. Countless interactions between large predators likely occur far beyond human awareness. The scar on the Guadalupe shark became a symbol of the ocean's enduring mystery. It reminded people that despite centuries of exploration, the sea still contains secrets capable of challenging scientific assumptions. Climate change may make these mysteries even more important in the future. As ocean temperatures rise, predator behavior appears to be shifting. Sharks are being observed in regions where they were previously uncommon, and some species are altering migration routes and hunting strategies. Changing environmental conditions could force deep water animals into new habitats, increasing encounters between species that rarely interacted